Welcome to EduNovo's practical session of focal length of concave lens. In our day-to-day life, we use concave lens in the spectacles to correct the nearsightedness. It is also used in the flashlights to observe wide beam of light source. A convex lens is thick at the middle and thin at the edges. It is also known as converging lens because it converges the light rays incident on it. A concave lens is thin at the middle and thick at the edges. It is also known as a diverging lens because it diverges the light rays incident on it.
Consider a convex lens L1. O is the optic center of the lens and the line passing through the optic center is the principal axis. First and foremost, an object needle O is placed on the left side of a convex lens L1 and its real inverted image I is located by the image needle. Now, the concave lens L2 is placed between the convex lens L1 and the image needle I. The concave lens diverges the rays and now the image is formed at I dash. Here I is the virtual object and I dash is the real image. Here the distance between O2 and I gives the value of U and the distance between O2 and I dash gives the value of V.
Now you got a clear picture about the terms associated with the concave lens. Let us go through the aim and the apparatus required to perform this experiment.
The aim of this experiment is to find the focal length of a concave lens using a convex lens. The apparatus required for this experiment are optical bench with 4 uprights, convex lens, concave lens, 2 optical needles, knitting needle, and a half meter scale. Consider a convex lens and mount it on the optical bench at a convenient position. Now, place an object needle at 1.5 times the rough focal length of the given convex lens. By adjusting the position of the object needle, you will observe an inverted image of the object needle on the other side of the lens. Now, we need to place the other needle on the optical bench and consider it as image needle. Adjust the position of the image needle until you find the image of the object needle on top of the image needle. Now, introduce a concave lens in between the convex lens and image needle. As the concave lens diverges the light rays, the image of the object needle is formed at further right. So, move the image needle to the right side until it coincides with the image of the object needle. Here, the distance between concave lens and image formed by convex lens is U and the distance between concave lens and image needle is V. Here, we need to obtain the image of a distant object on the screen. When you look at the window, you can see the tree which is a distant object. Face the lens towards a distant object and obtain its inverted image on the screen. Once you got the inverted image, move the lens forward and backward until you get a sharp image. Now, with the help of a scale, measure the distance between the lens holder and the screen, which is nothing but the rough focal length. Here, it is 10 centimeters.
After finding the rough focal length of the lens, fix the lens in the lens holder and then place the holder in one of the upright and mount the lens on the optical bench at a convenient position. Here, the lens is placed at a position of 100 cm mark on the optical bench. Now, fix the object needle in another upright and mount the object needle on the optical bench in such a way that the position of the object needle is beyond the focus of the lens. As rough focal length of the lens is 10 centimeters, we need to maintain a distance more than 10 centimeters between the lens and the object needle. Here, I am placing the object needle at a position of 85 centimeter mark on the bench. Now, to locate the inverted image of this object needle formed by the lens, we use another needle known as the image needle. Now, fix the image needle on another upright and mount the image needle on the optical bench so that the lens comes between the object needle and the image needle. Now, after placing all the uprights, we move to the right end of the optical bench to observe the inverted image of the object needle. Now, closing one eye, looking into the convex lens, adjust the positions of the uprights until an inverted image of the object needle fall on the image needle. Here, you can see clearly that the inverted image of the object needle over the image needle. Now, by giving lateral motion to the uprights, we bring the inverted image of the object needle and the image needle in the same vertical line. Here, you can see the inverted image of the object needle and the image needle in the same vertical line. After that, by adjusting the height of the image needle, we can coincide inverted image of the object needle with the tip of the image needle. Now, if we move our eye to the right and left, there is a relative shift between the inverted image of the object needle and the image needle. That means there is a parallax. To remove the parallax, we have to adjust the positions of the uprights until there is no relative shift between the inverted image of the object needle and the image needle. Here you can see clearly, as I move my eye to the right and left, there is no relative shift. That means parallax is removed. After removing the parallax, we have to note down the position of the object needle, lens and the image needle.
The rough focal length of the convex lens used in this experiment is 10 centimeters. Observation table. Object needle O. In the first arrangement, when the object needle, convex lens and the image needle are placed on the optical bench, then the inverted image of the object needle without any parallax was formed on the tip of the image needle. The object needle was at 97 centimeters. Convex lens was at a position of 116 centimeters. Image needle was at a position of 136.2 centimeters. Now, in the second arrangement, when the concave lens is introduced in the optical bench, then the inverted image of the object needle is formed on the image needle without any parallax. When the position of object needle and convex lens are not disturbed and the concave lens is at a position of 131.2 centimeters, then the position of the image needle is at 138.5 centimeters. Observed distance U is L2I, which is the distance between the concave lens upright and the previous position of the image needle upright in the first arrangement. L2 minus I is equal to 5. Observed distance V is L2I dash, which is the distance between the concave lens upright and the new position of the image needle upright in the second arrangement. L2 minus I dash is 7.3. Corrected distance U is equal to observed distance U plus index correction U. Index correction U is equal to 0. Corrected U is equal to 5 plus 0, that is 5 centimeters. Corrected distance V is equal to observed distance V plus index correction V. Index correction V is equal to 0. Corrected V is equal to 7.3 plus 0, which is 7.3 centimeters. F is equal to 15.86 centimeters. Similarly, the other observations are as follows. F is equal to F1 plus F2 plus F3 divided by 3, that is equal to 15.86 plus 15.6 plus 14.65 divided by 3, which is 15.37 centimeters. Precautions. Focal length of the convex lens should be less than the focal length of concave lens so that the combination is convex. The surface of the lens must be clean and free from dust. Tips of the object and image needles should lie at the same height as the center of the lens. Parallax should be removed from tip to tip by keeping eye at a distance of at least 30 centimeters away from the needle. The distance between convex lens and object needle should be in such a way that only real and virtual image is formed. Index correction should be properly determined and must be applied for both U and V.
Now you are able to determine the focal length of concave lens on your own without any doubt or hesitation. Thanks for watching this experiment.